Okay, we're going to learn how to rationalize the denominator. And the reason for this is because we don't like an irrational number to be in the denominator. We are much more comfortable as mathematicians have rational numbers down there. So we just breathe better. It's just nicer. We like it better. So this one's not too bad. I think most students kind of would know how to get that square root of 3 out of there. We have to multiply by something. So if you multiply square root of 3 by, say, square root of 3, that should simplify pretty nicely here. So in the denominator, you have square root of 9, or you could just say 3 there. And up top, you have 2 square root of 3. So we just kind of transferred that radical from the denominator up to the numerator. But in doing so, now mathematicians are happy. We breathe easier. We like it better when there's rational numbers down in the denominator. Same thing over here. We can multiply by square root of 2 over square root of 2. That should rationalize the denominator. Square root of 2 times square root of 2 is square root of 4, which is 2. And up top you have 4 root 2. In this particular case, it would probably simplify even a little bit more because 4 and 2 simplify or cancel there. And so we get 2 root 2. Now this is where it gets a little trickier when your root is bigger than 2. So in this case, I think this one is not as intuitive. I would say that first example, most students kind of almost intuitively get. The problem with this one is it's tougher. I mean, multiplied by the cube root of 2 here would just give, over here you would have cube root of 4 or cube root of 2 squared. Well, cube root of 2 squared doesn't simplify at all, or it doesn't simplify very nicely at all. So I don't think that's what we want. What you do want to think about is, ideally, what would we like down there? We want that to simplify. We want that to be a nice number down there that's not a radical. So we want to get rid of this radical. I need 3 of something. Right now I have 1, 2. I need 3 of the same thing. So I really want down here to be 2 to the 3rd power. Because if that was the case, I would get 2 as my answer down here, which I would be very, very happy with. So you think, what do we need to multiply to get what we want? We want a nice, perfect cube down there. We want 2 to the 3rd. I have 2 to the 1st, which means we're going to have to multiply top and bottom by the 3rd root of 2 squared. So we need 2 more 2's, top and bottom, in order to have 3 down there total, which will nicely simplify. So up top, we now have a cube root of 2 squared. Or if you prefer to write that as cube root of 4, that would be okay as well. And you got it. Simplify. Let's try another one here. So this is a 4th root. I'm trying to do a couple different weird examples here of this, so it starts to make sense. Again, I don't start with what I need to multiply. I start with what do I need. Begin with the end in mind is what I do. So I have 1 3. I really want a group of 4 3s. So I need 3 to the 4th power. That's my goal here. Because if I have 3 to the 4th power, I am so happy. Breathing easy. Got a rational number down there. That's what I want. So what do we have to multiply over here, top and bottom, in order to have the 4th root of 3 to the 4th? I need 4 3's down there. I only have 1. I'm missing 3 3's. So this would be 4th root of 3 to the 3rd. 4th root of 3 to the 3rd. So this would be 4th root of 3 to the 3rd. Or you could write it as 4th root of 27. That's a 4 right there. Just really sloppy 4. There you go. And you get that one. There's one more. If you can do this one, you could pretty much handle rationalizing the denominator. I tried to pick out some tough examples. This one is pretty tough. In this case, again, you want to think about what do we want the denominator to be. You know, we need 3rd root of something. We need that something to be nice, simple numbers so that when we simplify it, it's just an integer over here. Or some just maybe a variable or something like that. So I really would like to have 3 x's right there, but I already have more than 3. So I really don't want to get a negative exponents. I don't recommend that. It's not going to work out well for you. So I think the next best choice here is a multiple of 3, in this case 6. If I have x to the 6th, the third root of that, I have two groups of 3 there. You could think of that as x to the 6/3. We've done a lot of that this chapter. So that would be x squared. Don't you breathe easier when that's nice and rational down there? So now we're going to do cube root. So in this case, we're looking for how many x's? We need 6 x's. I have 4, so I need 2 more. So cube root of x squared is what you're going to multiply by. Cube root of x squared. That's really as simple as you can write it there. So this would be cube root of x squared. There you have it.